My assigned protein is type 1 collagen. The mutation that I have is a dominant negative substitution of glycine for a larger amino acid in several locations. Collagen is the body's most plentiful protein, and it maintains structure in the body, so I chose the structural portion of it because it is part of your body's joints, ligaments, tendons, etc. The protein is normally found in animal cells. Subcellular location is fibroblastic, and it's usually in skin and muscle cells. With this mutation, the protein becomes less active. Collagen, type 1 collagen, the glycine supports collagen synthesis. So that's when the strands of collagen, or COLA, COL1A, come together to form the full collagen strand in its tertiary structure, so then it can join together to form the full tendon of collagen. And the substitution of a larger molecule, larger amino acid, means that it can't fold in its trihelix form, so it won't be able to form an actual trihelix like this, which is the wild type. As you can see, there are little pieces that are stopping it from folding into a helix shape. So with the substitution of glycine, that leads to a disease called osteoarthritis, which means that the collagen can't form tight bonds within it, so it bends out of whack. So the joints and muscles and tendons and ligaments are brittle and hard, and that inhibit movement, and they can form very apparent looking mutations, to say the least. So as I showed earlier, there are little pieces here. That would be the mutated larger amino acid. So glycine, the amino acid is small, very small. It's actually one of the smallest, if not the smallest, amino acid that out of the 19 that there can be. The substitution that we had wasn't specified if it was nonpolar or charged. Glycine is normally nonpolar, uncharged, and very small, but we do know that the substitution is much bigger, so it inhibits the folding process. As we learned in class, the tertiary structure of proteins has to do with its folding of the helix and beta sheets. And this will affect the function in a negative way. Like I said earlier, it has osteoarthritis. So the entire model is a kind of mock of what a tendon or a joint or like space between bones would be. These are also, collagen is also in bones. It's in 90% of the body. It's the most present protein in the entire body. The subunits are the, see if I can remember, the proline, the glycine, and there's one more amino acid. I think it's like triosine, something like that. But they're three, and they're small. We're all around the same sizes, and they form like a three little side-by-side line, and then those three little side-by-side lines come together. That's after the polypeptide. That's most likely your secondary stage. And then when it comes together in the strand like this, that's your tertiary. And then when it comes together in a big strand, how thick the collagen could be, that'll be your quaternary structure. And like I said, this is the wild type, and this is mutation. You can tell it's mutation because it has these little bits in here that are breaking up the folding. Obviously the model is very limited. I couldn't do as much as I wanted to, If I had more materials, like more, I use shoelaces to form the strands, but I'd probably have more thing on it that would give an actual look of primary, secondary, tertiary, and quaternary structure, but I just don't have that type of material. Yeah, and here's a 3D look at the model. So this will represent like the space between like a knee or something.